thing about ELISA. We extended it a little bit to also any other use of safety critical applications in open source. Basically because always there are more questions which are not directly Linux related. And it's not that I need to answer all the questions, because we have a bunch of working group experts, leads, practitioners, contributors. So everybody who wants to just speak up and say something, feel free to do so. I brought in this slide because I like it, but I don't need it. I can jump over it. I guess from what I hear from you, you all are pretty aware about the difference between safety and security. For the Germans, it's easy. It's always the same word, so you don't need to make up your mind on it.
Which confuses the rest of the world, but that's okay.
Yeah. The next one is a bit on standards and processes. I still remember the beginning times where we discussed a lot about which standard is actually the best and the one and only safety integrity standard we should talk about and so on. So it was like a half a year of discussion until we figured out basically they all expect very similar things in the one or the other rigor. So it's they represent the best practices of the industries. They have requirements, documentation, testing, and all these kind of things. The rigor they apply, certain measures may differ, but still, in principle, they want to see the same traceability and artifact. And anyway, you need to know the whole system, and there has been safety before standards, so the challenge remained the same independent which standard you apply. And this is actually all the nice thing about the ELISA environment with the horizontal and vertical work groups, because we see that there is exchange between industries, that there's demand and the principle and the mechanisms can be changed or exchanged, yeah. My touch points, so sorry that I don't bring in the railways part or the aerospace standards here. We have the 615.0a, which is still the metal standards, Root 3 as this typical argument, just what's brought in. Part 8, Clause 12, which gets extended, enhanced, how would you call it, like this with the ISO pass 8926, right? So it migrates into it. And what we see, what is really a must or a need with all these different kind of standards, also with the previous page, still they are already existing since a long time, but Linux is far more complex. And also, if you not just take Linux in the boat, the system's getting far more complex. So it's really a lot about system understanding, system engineering, and you face certain challenges if you want to take recent modern software development practices into the standards world, which was quite often developed originally for a microcontroller space with a 10,000 line code or something like this, but not for 100 million lines of code which are in the car these days or even beyond. Yeah, so therefore as an introduction and motivation, we need to see that standards need to adopt to the increasing complexity of the products, and we need a robust fundament on the processes, technical measures, statistical analysis. We'll see this in the agenda of the next days. We're seeing a more and more growing interest in open source in various industries. The transparency is a helping hand, but it's sometimes hard to understand like how community evolves and works and how to make the same arguments then. And yeah, that makes it hard to get this into safety standards compliance. However, I just make this one part. There are already many evidences out there, and I think the strongest evidence on seeing Linux being used in critical environments, especially in China, where you see most of the driving assistance systems on level 2++. I don't know much about the safety certification for those products because I don't speak Chinese, but you can make your own investigation on what it means. We'll focus mainly on the Linux side, so all the ecosystem around it during the next days. And just for the role of Linux, we see that it's the open source superlative, so it's the biggest, largest, fastest commits environment. If we take just the kernel, all the flavors also, so you have really this superlative really there. If you manage this to get your safety critical argumentation through, you will most likely have also easier times for all. Still, we collaborate on a lot of things. Now, there was a little hype when ELISA was started. We saw that there was a little bit less traction in there, but now, like the last 2 to 3 years, with all these software-defined vehicle, and not only in automotive, but also in aerospace and other things. So we see there's a ramp up again, a higher interest in bringing this forward. We get more practical examples, more member companies who provide solutions, and so on. So that's where we work in ELISA. And yeah, then of course Linux differs from the traditional RTOS, right? We have microkernel, well, it's monolith. We have like hard real-time scheduling versus more soft real-time. Even if you preempt RT configuration, you don't have guaranteed real-time at the end. However, if you just come with your little small RTOS, whatever you have, and your little small part, and you want to build a, like, say, multi-core high-performance compute with various gigabyte of RAM, multi-level caches, hundreds of sensors, interactions, network parts, and so on. You can also try to solve this with a small RTOS on your own in a closed proprietary environment. It's possible potentially, but it also brings you the complexity. So it's the thing that we handle complex systems. The complexity is growing in the way how architectures are created, just for the connection of all the parts of the system. And by this, you sum of needs to faiths. Some parts, and then of course Linux brings special challenges, but it also brings a lot of opportunities due to the size, ecosystem, environment, and so on. Project orientation, ELISA stands for enabling Linux and safety critical applications. So it's with Linux, it's beyond security, as we mentioned. We really look into dependability and reliability. That's what you see from the agenda, where we go into up to the compilers goals, down to the Linux kernel, up into the user space, doing certification pathways. We have for this all the use cases there. Have the distributors in place who are member companies who join. We interact with Zen, Zephyr, SPDX, Yocto, AGL, which is nice because we have all the representations here in the room also. And if you go back, it's like a standard slide. It's not that I created it for now. Within the reproducible system, we have presentation for this as well, and look really into the elements, process, and tools. And that's where the members subscribe to in our mission statement that we get a set there, and which is at the end amenable to safety certification. We will not safety certify. We'll see this briefly in a second. It's just like the path forward. And this also is one of the standard slides which basically always come in.
Pretty much since the beginning, actually.
Yeah, it's still almost since the beginning, yeah. And I think it was, at this time, she was in that phase for the technical steering committee chair, and she was saying it the first time. Assessing whether a system is safe requires understanding the system sufficiently. And then you need to understand Linux within that system context, right? It's not everything which is maybe the thing you need to have in Linux. How do you tailor it? Which parts are crucial to safety and so further. And then you need to see from these components, right, where is the relevancy? What can you tailor out? What do you have to keep in? And then you need to do really the gap analysis on it. So you need to identify this, where more work is needed. And that's what we see from all the member companies interacting here. Some parts we cannot do from the ELISA project is to engineer your system to be safe. That's the responsibility of those who create the product, because we cannot see the full use case, the full environment. We can only propose processes, tools, describe them, but we cannot guarantee that they are really executed. We also cannot create the one super long-term support kernel out of tree, whatever, local maintenance thing. We need to stick to the mainline for the update reason, for maintenance efforts, and so on. There is this story, I still don't find the evidence, and I told it multiple. There was a company which actually, according to Nicholas McGuire, I think he said it once, was certifying the 2.4 kernel. And at the time they were done with the 2.4 kernel, the 2.6 kernel came out. I think it was like, and then the business model was done.
I've got another case study from a company in Germany that it took them 6 years to get the Linux kernel certified, but they did do it eventually for their specific case, where they had Linux in there, but it was a 6-year. Make it easy for people to move faster.
It's a 6 years iteration for one kernel version. This is like, and still while we, yeah, and we also don't take legal obligations, so we don't build a safe Linux within ELISA. We just give parts, and the partners within ELISA take the responsibility to bring this forward. And we have a set of strong partners in here. You see a bunch of them presenting. So we have Boeing presenting, NVIDIA, Red Hat, so like our premium members who really be there. We see the Coldstream, Electrobit, Solution Canonical, of course, as our host here, and also his presentation. Also, not if everybody is here. So we also have other members who bring in things. So we have Wind River here. Wind River brings solutions in the space. Dynatronics is a strong partner there as well. I hope we have virtual presentation and participation there. And we also get associate members, which basically show that we are interacting with other communities. Show you how this is set up. We work on the horizontal work group for safety architecture. Gab is here, will present on the requirements. We have the Linux features with Alessandro, who will present later on. The tool is currently paused. We will move on with it. So here there are potential interests. Already ELISA T would like to talk a bit more about it. Then we have the engineering process with Paul, who is here. Systems led by me. Aerospace is by Boeing. Matt will join later on for the Zen part presentation by Ian. And yeah, automotive just kicks off again with Anton being participant virtually today. This is something nice. And medical, we look at today. We also don't have a medical participant. Yeah. If we bring a new medical use case in a company who is interested in buying it.
There'll be a seminar.
Not switched on.
There'll be a seminar showing up this summer from one of the Loop folks in terms of how they're using it with Linux there inside that. So that'll be showing up again. So there'll be some interest starting again there, I think, this summer.
Right. Good. And the different relation of the work groups, basically that the use cases feed the horizontal work groups, and the horizontal work groups align on things. And this gets into various kind of deliveries later on. And then there is an exchange between everybody, which makes it sometimes hard and sometimes easy to bring things together or do things in parallel. So we're not perfect on this, and we're working on it, but that's why you sometimes get a bit confused. And the best, when you start joining, just go to the TC, look for a best slot where your interests are best covered. Right. We really loved the interactions between the communities. And I'll quote George Bernard Shaw on this. Like, if you have one apple and I have an apple, and we exchange these apples, then you and I will still have each one apple. But if you have an idea and I have an idea and we exchange these ideas, then each of us will have two ideas. And that's basically what is a nice thing which we have, which we see also when we interact with Zen, Zephyr, if we like the different automotive, also to the Eclipse side, into another foundation, or go like in the further outreach. That's there. And we really bring a strong community. So I started the previous session with the thanks to Canonical. I had the members. I just took the pictures from the last workshop and our booth at the Open Source Summit, because we will have this again with Bennett Plumbers, with the other picture in the button. So that's there. And just a few things. I think I already covered most of it, but it's good to repeat sometimes the one and the other thing. So we look for a lot of structured documentation, testing to requirements, traceability, keeping documentation, synchronize with code. This is one of the big challenges which we need to look into. Achieving maintainability over decades, right? We are in regulated industries which really are a long, long time in operations. How do we make this? And also what's needed to create a system. Independent which project you look at in these different kind of projects which are there on the open source side, you still always get an argument that open source is not developed and organized like commercial software, because nobody's there with a strong funding and paying the developer to spring. It's a completely different culture there. You have less influence on maintainers, which is good and bad at the same time. So you cannot directly reach out to them sometimes, and maybe never met them in person, but work for them and with them since years. You can also harder train developers. You have harder argument for the liability, because like who's that person with this GitHub handle you have never seen before in the project. But you get still commercial suppliers on it. You have all the V model parts. And if we just see like on these challenges and also on the requirements, I did a quick check on what we have during the next 2 full days. And we have around 7 talks which touch the verticals. We will have roughly 4 on the system architecture, how systems are composed. We have around 4 on testing, tracing, requirements and their tools is another one, standards and processes. I don't know why I have twice tools. Anyway, really in the kernel space, they're also down where I think we will have roughly 4 which go down to the kernel code. And then also to look into adjacent community, that's also around 7 again. I had this last time and I updated it, and I was happy that we get a good mixture like on the wider top sides, and then a good spread on all the different fields, because this was feedback from past workshop that this was not always aligned. And so then it's time to the question, because all the topics will anyway come. I check also for the chat if someone has a question.
No one's pasted anything in the chat, but I put a prompt in there to encourage ones. But does anyone here in the room have any questions about this? Yep, go for it.
I have a non-technical but operational question. I might be the only presenter with a hybrid mode, that Matt is online and I'll be in person. So do I need to join the invite?
No, we will hopefully have it in this way that you just plug in and they stream it. Okay. So you will be then the event space main speaker, and they should also somehow share the content. While I haven't seen how this is shared. Oh yeah, it's shared by the screen, yeah. So Matt, I don't know if Matt will also present something. Okay,
so we
okay,
just
then
need
it should
to
work
be
out.
unmuted. We'll talk.
Yep.
We'll check with the AV.
Otherwise,
folks
also Matt
afterwards.
can present something, and we should see when Matt presents something. We should also see it here.
Okay.
So your choice. If you join virtually, but you don't have to. All right.
Anyone else have any questions from here, or do you guys have a rough feeling? Oh, okay. Has it changed since the last time you participated?
Yeah, not a question, but a comment on what you said, that systems are becoming more complex, but also the tools that we now have, which is mainly AI, also gives us capabilities that we didn't have before. So that should offset the complexity of system being more complex. I mean, right? Problems are getting bigger, but we have more tools to solve them. We should take that into account.
Yeah, that's a fair comment. And then we also get the additional part, like how much can we trust these kind of AI tools? We are driven by a lot of determinism. Maybe also AI topics can help us then again on the Linux argument, if we find a good argument. Because, I mean, it's on the one side where the people say Linux is non-deterministic. Then they say it's still too deterministic, and it's not... right? It's depending on how you make your argument. You make your argument and say, well, Linux is deterministic. Then they say, no, it's not. Then you say, okay, let's put 2 Linux next to each other. Then it's because it's non-deterministic, it will not behave. No, it will still cause the same failure at the same time. And it's like, okay, then it's somehow, again, deterministic. And I guess AI will also help us in these parts. And I hope really for the nice discussion tomorrow morning in the AI space. Eric.
So I'm going to immediately derail the discussion and talk about the parts that were not that bolded in your introduction. I happen to have to work a lot with PLCs, and because PLCs are basically the entirety of the ecosystem of safety critical software in a rail vehicle, at least that's the state of the art. Are there any bridging points between the PLC world and what we are doing here? Are there any projects that aim to do the same thing as a PLC does in an open source fashion? I mean, an RTOS kind of does a similar thing, but it's not quite following the same requirements that PLCs have to follow at the moment.
So from the ELISA side, we do not have that much which came directly as a PLC space. But I actually have been in touch with some companies as part of the ELISA project, like because I'm based close to Hanover and there's Hanover Fair nearby, and you see all this automation, and you see also there that they are coming to a software-defined industry, and where they start bringing in PLCs, combining them with x86 PCs, showing use cases how good already preempt RPT is doing for their industrial use case, because they may require real time, but the real time part is always depending on like which machine they're doing, if they really need always this 1 microseconds, if it can be a little bit of jitter around there, how much is the likeliness that something fails, and what does it mean for their production. And in this way, you see that Linux suddenly gets in. And also other artists, of course, like Zephyr's there as for smaller devices. I mainly went there as ELISA, therefore I got all the ELISA parts. But this was also the step where people said, when we go on the one industry, and we're doing it, for example, in automotive, we go through the certification, we go through certain standards, and we go through certain robustness. Super simplified. We add a little bit of our additional real time on top, and we can serve a lot of industry needs also in this. And that this makes sense. You can see like from the last, was it CES, where they suddenly all came up and was like, we're car manufacturers, now we build human robots. I mean, the same thing, right? They say the technology is there, and why, as a Linux provider, you shouldn't go for the same argument and say, I'm doing this, I already have the experience, I'm streaming camera, I let cars drive around using open source and Linux, why not using this in an environment and then overcome some hurdles from the SPS? But similar, like there is always a microcontroller space existing still. There will also be SPSs, I guess, or PLCs.
Just for the those who have not been PLC, do you want to expand what that stands for, please?
What is programmable logic
Controller.
controller? Yeah. Okay. I know always in the German word is SPS for the Germans who are more used to this.
Thank you.
I can add something to that. So we rely, like at AMD Xilinx, we rely a lot on the PLCs, the programmable logic, to do some of the real-time stuff. And the way we are interacting or sort of integrating it is that I can speak for Zen. Like in Zen, we are doing a lot of the real-time support for the memory protection unit, that is the R52, R82 class of the processors. And typically what we have is that we will have a very thin software system which will sit on this real-time logic, the PLC board, and it is going to do a very, very dedicated task. So in a way, we are just seeing at few thousands lines of code, which will do a very static kind of a thing. So that's one of the aspects. The other aspect also of the PLC is that it also depends a lot on the firmware, which is unfortunately not very open source. It depends a lot on the kind of, let's say, the real-time use cases that you have in mind. But we can talk maybe on that, yeah.
And maybe one last part, because we're here as
And
Canonical.
No, okay.
There is already existing PLC adoptions, of course, with Linux out there. So if you just look for the Control X, which the Rexroad people do, this came to my mind because we're here at this place where it's already in production. So you have, or which ones in industrial applications and the PLC near environment.
With that, then we will probably go on to the